Hello everyone. Today let us discuss about an electric field at a point on the axis of an electric dipole. Once again, let's uh, repeat the topic. Electric field at a point on the axis of an electric dipole. We know an electric dipole is a pair of equal and opposite point charges. There are two charges, plus q and minus q. They are separated by a small distance 2a. By convention, the direction from minus q to plus q is said to be the direction of the dipole. So this is the direction of the dipole. Its direction is from minus q to plus q. The midpoint of locations of minus q and plus q is called the center of the dipole. So the midpoint is called as the center of the dipole. The total charge of the electric dipole is 0 because one charge is plus q, other charge is minus q. Therefore, total charge is 0. The total charge of the electric dipole is 0. The dipole moment vector p bar of an electric dipole is defined by P bar is equal to Q into 2A into P cap. P bar is a vector. It is dipole moment. It is defined as the dipole moment. What is this dipole moment? It is the product of any charge of the dipole and the distance between the two charges. That is, P bar is equal to Q into 2A. In vectorial form, P bar is equal to Q into 2A into P cap. P cap is a unit vector in the direction of P bar. Now let us see the expression. That means let us derive the expression for the electric field of a dipole. We can derive it in two parts. The first part is electric field on the axis of the dipole, and the second part is the electric field on the equatorial plane of the dipole. In this video, we will see the expression for the electric field on the axis of the dipole. The axis of the dipole means a line passing through both the charges. Here in this picture, you can see plus q is located at A and minus q is located at B. The distance between plus q and minus q is 2A. The center of the dipole is O, and the line passing through plus q and minus q is a straight line which you can see in the figure. And the distance of a point P where we want to find the electric field is R from the center of the dipole. Once again, I repeat, we have taken a point P on the axis of the dipole where we want to find the electric field. This point P is at a distance R from the center of the dipole. Now, one more thing we have to observe, the electric field is a vector. It has direction. For a positive charge, the direction is always outwards. Therefore, in this picture, you can see the electric field due to the positive charge E plus Q is pointed in the outward direction, that is, from our right to left. And the second thing is electric field due to the negative charge is always inwards. In this picture, you can see E minus Q is pointed towards the negative charge minus Q. That is, the arrow is from our left to right. So E plus Q is our right to left. E minus Q is from our left to Right. Now, coming to the point, the distance of the point P from the center is R. Therefore, distance of the point P from A is R minus A, because AO is equal to A. OB is also equal to A. A to B is 2A. Therefore, AO is equal to A and OB is equal to A. Therefore, O to P is R. Therefore, A to P is R minus A. Similarly, B to P is R plus A. Why we want the distances? Because the formula for the electric field is E is equal to 1 by 4 pi epsilon naught Q by distance square. Therefore, we need to know the distance. Now, let us take this point P and calculate the electric field at the point P due to both the charges and add both of them. Then we will get the final expression for the electric field. Let's see now. The distance of P from plus Q is R minus A. Distance of P from minus Q is R plus A. Therefore, we have to take those distances and calculate. As I told you earlier, for a positive charge, electric field is always outwards. For a negative charge, it is always inwards. And P cap is a unit vector in the direction of the dipole moment P, that is minus Q2 plus Q. Now, coming to the point, electric field due to plus Q is E plus Q is equal to 1 by 4 pi epsilon naught Q by distance square. Distance, as already we have seen, that is from A to P, which is R minus A. Therefore, E plus Q is equal to 1 by 4 pi epsilon naught Q by R minus A whole square. Equation number 1. Now let us see the electric field due to minus Q. Electric field due to minus Q is equal to E minus Q is equal to 1 by 4 pi epsilon naught minus Q divided by distance square. This distance, as already we have seen, R plus A whole square. Therefore, total electric field, adding equations 1 and 2, we get E bar is equal to E plus Q bar plus E minus Q bar, that is equal to 1 by 4 pi epsilon naught Q by R minus A whole square plus 1 by 4 pi epsilon naught minus Q R plus A whole square. Keep everything in a square bracket. Outside the bracket, we have P cap. Once again, P cap is nothing but the unit vector in the direction of the dipole moment. So, let us add both of them. In these both expressions, Q by 4 pi epsilon naught is common. Take it out. Therefore, inside the bracket, we get 1 by R minus A whole square minus 1 by R plus A whole square into P cap, that is equal to Q by 4 pi epsilon naught. Inside the bracket, let us take LCM. LCM is R minus A square into R plus A square. With that, we get the numerator R plus A whole square minus R minus A whole square into P cap, that is equal to Q by 4 pi epsilon naught. We are taking A plus B whole square formula from algebra. Therefore, R plus A whole square is equal to R square plus A square plus 2RA minus, within the bracket, we are using A minus B whole square, that is R square minus A square minus 2RA divided by R minus A into R plus A. Everything keep it in a square bracket whole square. Within the bracket, we can see that is in the denominator, it is just like A plus B into A minus B. That is nothing but A square minus B square. Therefore, in this denominator, we get r minus a into r plus a, that is equal to r square minus a square and whole square. Therefore, E bar is equal to q by 4 pi epsilon naught 2RA plus 2RA, because in the numerator r square and minus r square is cancelled, a square minus a square is cancelled, and the remaining will be 4RA. 2RA plus 2RA is equal to 4RA. In the denominator, it is a square minus b square formula we have applied, that is equal to r square minus a square whole square, and keep it everything in a square bracket into p cap, that is equal to q by 4 pi epsilon naught 4RA r square minus a square whole square into p cap. And dipole is a small thing, very small thing, which we cannot even see with our eyes. It is like a molecule. In a molecule, we see positive charge goes to one side and the negative charge goes to the other side. Then it behaves like a dipole. That size of that molecule is too small. That means distance between positive charge and negative charge is too small, then it can be neglected. That means A is negligible when compared to the distance r. Therefore, remove A from the above expression. Therefore, you will get E bar is equal to q by 4 pi epsilon naught. For RA, we will divide like 2A into 2R, that is divided by R square whole square, because we have neglected A here, into P cap. Why we have taken the numerator as 2A into 2R? Because we want to write it as the dipole moment. Because we know dipole moment P is equal to Q into 2A. So therefore, Q into 2A will become P, and 2R, 2 we will write in the front. Therefore, 2PR, that is the numerator. Denominator, it will become 4 pi epsilon naught R to the power of 4 into P cap, that is equal to 2PR. We will write the denominator as 4 pi epsilon naught R cube into R. R and R in the numerator denominator is cancelled. Therefore, we will get E bar is equal to 2P 4 pi epsilon naught R cube into P cap. So finally, we can write the expression of the electric field on the axis of a dipole at a point P, which is at a distance r, is equal to E bar is equal to 2P bar divided by 4 pi epsilon naught into r cube. Once again, E bar is equal to 2P bar whole divided by 4 pi epsilon naught into r cube. This is the expression for the electric field on the axis of a dipole. In our next video, we will see the electric field at a point on the equatorial line of an electric dipole. Thank you for watching this video. Till we meet in the next video, bye to all of you.